Hi class, let's take a look at problem 10a. Now, I provided the graph of this one and notice that we don't have any x-intercepts. So this is an indication that we're going to get complex roots. So in this case, before we evaluate into the quadratic formula, technically the values of a is equal to 1, b is equal to -1, and c is equal to the values of 9. So the quadratic formula is going to have a negative b plus or minus the square root of b squared minus 4ac divided by the values of 2a. So x is equal to negative, b is a -1, plus or minus the square root of -1 squared minus 4 times 1 times the values of 9 divided by the values of 2 times 1. So x is equal to 1 plus or minus the square root of 1 minus technically the values of 36 divided by the values of 2. So x is equal to 1 plus or minus the square root of -35 divided by 2, which happens to be x. Well, let me just rewrite it as 1 plus or minus I square root of 35 divided by the values of 2. In this case, the solutions end up being complex, and you can rewrite them as x is equal to 1 plus or minus I square root of 35 divided by 2, or actually separate them. X is equal to 1 minus I square root of 35 divided by 2, or x is equal to 1 plus I square root of 35 divided by 2. These are both of our solutions, and remember that in this case, the property that I'm using here is that whenever you have the square root of -1, this represents the imaginary unit of I. So as I'm simplifying the negative, it just comes out as an I. That's actually it for this problem. Once we end up with the I solutions, that's an indication that you don't have any x-intercepts, and well, the parabola, it's up here.